Hello, friends. In this lesson, what we're going to look at is using the unit circle and finding exact values of trigonometric ratios. Now, before we do this, what I would like you to do right now is go get a scrap piece of paper. I want you to take a few minutes, draw out the entire unit circle, draw it nice and pretty, and come back when you're done drawing that so that we can look at how do we use it to find these exact values. So go take some time and draw that. I will see you in a few minutes. Okay, you're back and you've drawn out the unit circle. And hopefully it looks something like is drawn here. So maybe take a moment to check your coordinate pairs are all correct. But I'm sure you did. The other things I like to write out on my page with my unit circle is it's always helpful to remember the equation of the unit circle. Probably a diploma question right there. I like to write this little cast law or rule, whatever most teachers call it. Again, that tells me which trig ratio, cosine, sine, tangent, or all, which one is positive in which quadrant. Those are the important pieces. Now, I want you to write down something else that's really, really important that we talked about in the other videos. If we go and look at any angle here, and I'm going to, again, go back and draw my triangle in. What this tells us is at 30 degrees here, this coordinate pair tells me the y value is a half, the x value is √3/2, and the hypotenuse or the radius has always on the unit circle a length of 1. So how is this super helpful? Well, if I'm thinking about what sine 30 degrees would be, going back to grade 10, I would say this is opposite over hypotenuse. Well, look at what we have here. This would be 1/2 over 1. Well, 1/2 divided by 1 is just a half. And if I said, what's cosine 30 degrees? Well, going back to grade 10, I'm going to say that's adjacent over hypotenuse. So this would be √3/2 divided by 1. And that's just going to be √3/2. So one of the beautiful things about the unit circle is when the hypotenuse or radius is 1, it simplifies our work when we're trying to find these values. Now, here's what's the link I really want you to notice then, is let's look at these coordinates that are given right here. Look at this, √3/2. √3, oops, it just moved on me, is √3/2 right there. 1/2. 1/2. So guess what? Here's the other rule I want you to write down on your page. Any point on the unit circle. So if we are used to thinking as a point as the point x comma y, on the unit circle, I want you to think of this. X is the value of your cosine ratio and y is the value of your sine ratio. This is very important for the rest of the unit. Okay, well, how does this help us? This is going to help us find exact values. That's the whole purpose of us having the unit circle. So we're not rounding values. Even better, we don't need a calculator. That being said, make sure your calculator is beside you because we're going to use our calculator to check our work when these questions get a little bit more difficult. All right, let's do a few easy questions here. Okay, let's take a moment and we're going to find the exact values of the following 3 trigonometric ratios: cosine 60, sine 225, and cos 660. So when I see this word exact values, the first thing I want you thinking is, let's go look at our unit circle. So I go to 60 degrees right there. It says cosine. Cosine is my x value. So cosine 60 degrees is 1/2. Done. Easy peasy. We don't need a calculator. Let's try the next one. Sine 225. So unit circle, 225. Sine is my y value right there. Now, the only thing I need to watch for is making sure that ratio is negative, like it tells me it is. Easy. Cosine 660. Okay, exact value. I go to my unit circle. 660, wait a minute. That's not on my unit circle. I only go to 360. Well, here's where we're going to use that idea of coterminal angles. I'm going to find my principal angle. So what do I know? 660, well, it's more than one revolution. So what I'm going to do is say I'm going to subtract 360 from that. So if I subtract 360, we're at 300. The ratio of cosine 660 is going to be equal to the ratio of cosine 300. Go to my unit circle. There's 300. Cosine's the x value. It's a half. That's it. I was just able to find the exact values of these things without a calculator. But I have a calculator, so how is it going to help me? Well, let's go and grab our graphing calculator. Okay, so here's my graphing calculator. First thing I need you to do is I'm going to go check my mode and make sure that I'm in the mode that the question says. The questions we're doing right now are in degree mode. Good. Go back to my main page. Okay, what did we just find? We found the exact value of cosine 660. It says 0.5. Guess what? You told me the answer was a half. So my calculator matches what my unit circle told me. So I want us using our calculator to check our work. Let's try this again. Let's look at a couple more difficult questions and use our calculator to check our work. All right, let's look at finding something more difficult. The exact value of tangent 120. What's the exact value of this equal to? Well, I go to 120. It's right there. That's great. But tangent isn't part of my points. Well, x is cosine and y is sine. So how do I get tangent? Well, let's think about this for a second. Tangent, going back to grade 10, is opposite over adjacent. Well, in this case, the opposite is the sine value. It's y, isn't it? Like this is y over x. So opposite in this case is sine theta, and tangent is going to be sine theta over cos theta. This is on your formula sheet. Maybe go and take a look for it right now. Tangent is opposite over adjacent. It's y over x, but I want to think of it in this lesson as sine over cosine. So when I get the exact value of tangent, I can't just read it right off the unit circle. I'm going to have to do a little bit of work, but no big deal. What is it? It says sine, that's my y value, divided by cosine, which is my x value. Also watching, it's negative. Okay, there's a little bit of work here. When I'm dividing fractions, I multiply by the reciprocal. And I simplify. So 2 divided by 2 is 1. I've got root 3 over negative 1. Well, let's just simplify that down. I mean, that's not really wrong if you left it there, but, you know, we want to simplify it if we can. Negative root 3. That's it. Okay, I want to check my work. Is that my answer? Well, let's find out. Let's go to our graphing calculator. we just said we were trying to find the value of tan 120. So we go to our graphing calculator and let's put in tangent 120. Gives me this long, horrible looking decimal. How do I check my work? Well, I thought the answer was negative root 3. Look at that. The two sets of decimals match. So what does that tell me about my work? It tells me what I did was correct. So as much as the point of using the unit circle is to not look at our calculator, I want you checking your work. That is important. Okay, so we just learned something else new that I want you to go and find on your formula sheet. That tan theta is really opposite over adjacent, which is really y over x, which is now sine theta over cos theta. This is known as an identity, which we will talk about in later lessons. Okay, so this is how this is going to work for the entire lesson today, finding exact values. The only other thing we need to know is we know sine, cosine, and tangent. We know these are our primary trigonometric ratios. Well, in 30-1, we need to look at the reciprocal of these. So we need to look at the reciprocal of these. These are known as our reciprocal trigonometric ratios. Well, 1 over sine. Okay, I'm just going to flip my y value if you want to think of it that way. 1 over cos. I'm going to flip my x value if I want to think of it that way. But these have names. These are functions. So these are their names. 1 over sine is called cosecant, CSC. 1 over cosine is called secant theta. And 1 over tan is called cotangent theta. These are right on your formula sheet. And if you notice the word secant, sectant, this all came from ships navigating the seas, but that's another history lesson that you can watch another time. So that's where these names actually all came from. So let's take a look at one of these. How do they work when we're trying to find exact values? Let's find the exact value of cosecant 60 degrees. So cosecant is this new reciprocal trig function. It's brand new to me. So I go to my formula sheet, and what my formula sheet tells me is cosecant is 1 over sine theta. Okay, so how is that going to help me? Well, let's just go and find what sine theta is first. What's sine 60 degrees? So 60 degrees, sine's my y value, it's root 3 over 2. Well, if I know what sine theta is and I'm being asked what the reciprocal of it is, all I'm simply going to do is then say this. Cosecant 60 degrees is the reciprocal of this. There it is. That's the exact value of cosecant 60 degrees. Now, my friends, technically that is your answer. However, sometimes you may be asked to rationalize. So to rationalize, it's been a while, we multiply top and bottom, numerator and denominator, by root 3 over root 3, because that's really us multiplying by 1. We're not changing the value, we're changing how it looks. Then we simplify, that's 2 root 3 over root 3 times root 3 is 3. There it is. So these are both acceptable answers. However, when you're looking at a multiple choice question, you may have to rationalize the denominator. That's it. So we've got these 3 new reciprocal trig functions. They work really the same as sine, cosine, and tangent. They're just the reciprocals of what we know since grade 10. All right, one more question for us to look at, and you are good for the lesson. Okay, the last sort of question you're going to see in your homework. Determine theta if tan theta is equal to 4 over 3 and sine theta is less than 0, where 0 is less than theta is less than 2 pi. Okay, this is a very common type of question where we now have to go and think about where are we drawing this on our Cartesian, on our quadrants, right? The word determine means I need to show some work. So tangent, well, what does it say? Tangent is 4 over 3, but it doesn't say it, but what it's trying to tell me is tangent is positive. So I go back and I write my cast. Where is tangent positive? Well, tangent is positive here and here. So I could be looking to draw a triangle in 2 different quadrants right now. But then what it tells me is sine is less than 0. Sine is negative. Well, what quadrant is sine negative? Well, sine is negative in quadrant 3 and in quadrant 4. So which one is satisfied both conditions? Which quadrant? Quadrant 3. In quadrant 3, tangent is positive and sine is negative. So we are going to draw our triangle in quadrant 3. Something like this. Now, the point that they're giving us here, tangent, which is opposite over adjacent, which is y over x, right? This isn't on my unit circle. It doesn't say it's on my unit circle, but it's a triangle right here, okay? So I don't know if it's on my unit circle. It doesn't tell me that. In fact, it's not on my unit circle. So I'm not going to look at my unit circle here. I'm going to think of just a triangle, and I'm always going to draw my triangle like that to the x-axis. Now, I'm going to label my sides. Tangent is opposite over adjacent, and this is really important, so watch really closely. Tangent is opposite over adjacent. So this is 4, that's opposite. This is 3, that's adjacent. I see this all the time, and I just made a mistake. Think of where we are on the Cartesian plane. We went left from the origin and we went down from the origin. Those values are not positive, they are both negative. This is a very common sort of thing that goes wrong in these questions. We need to be watching for our side lengths. Perfect. Now, what we're going to do is we're going to find this angle. So where is theta? So when I'm doing these questions, I want to think theta is measured always from 0 to my terminal arm where I end. There is theta, and I always label that in. What we're going to do, though, is look at our triangle. Theta is not contained in our triangle, is it? So what you're going to do here is you're going to find this reference angle right there. I'm going to call it RA. So what we're going to do first is we're going to find this reference angle. So tan of my reference angle is 4 over 3. I notice that I need to find this angle. So I'm going to tan inverse both sides. Just like that. So I'm left with just RA, my reference angle. Some people call that alpha, so don't be scared if you see that. Some people call the reference angle alpha. It says I'm going to put this into my calculator because it's not on my unit circle. I also have to be careful what mode I'm in. My domain is in radians, so I need to switch my calculator to radian mode. So I go and put this into my calculator. Tan inverse 4 divided by 3. We're going to get an angle of 0.9. I'll go to the nearest thousandth radians. Okay, so what is theta then? Well, theta goes, it's our red line here. It goes from 0 to our reference angle. So to find theta, what we're going to do, what's theta? Well, theta is going to go all the way to pi, right there. And it's this extra little chunk that is our reference angle. So theta is pi plus our reference angle. Theta is pi plus 0.927 radians. And we stick that in our calculator. And what do we get? We are going to get a value of 4. I'll round to the nearest tenth here, radians. So the last question you're going to get in this practice is about finding angles that aren't on our unit circle. When our angle is not on our unit circle, we're going to have to go back to rounding. If the angle is on our unit circle, there will be no rounding. So for instance, if I had asked instead, and I had said, what is theta if sine theta equaled √2/2? Well, now what I'm going to do is I'm going to go to my unit circle. I'm just going to erase all of my sketches on it. And it says when sine theta is equal to √2/2. Sine is my y value. Sine is √2/2 right here. And sine is √2/2 right here. So my angle, if I was in radians, would be pi quarter and 3 pi quarter. Just like that. So unit circle, no rounding. Not on the unit circle, we're going to have to do some rounding. Okay, friends, that should take care of this lesson for you. I will see you in the next one.